Hi everyone, Mark here from Couchbase. Today I'm going to talk about the impact of application downtime on business and how to eliminate it completely. It's no surprise that for enterprises, every minute of app downtime translates directly to lost revenue and eroded brand loyalty. Couchbase is an operational data platform for AI that ensures your mission-critical mobile apps remain fully functional and synchronized, regardless of network availability. By being deployed at the edge, Couchbase Mobile eliminates the financial risk of internet outages and ensures your mission-critical apps are always on and always fast. Let me demonstrate how this works. Suppose I'm a large retailer with hundreds of physical stores. Inside every store, there are employees on the floor serving customers, in the back doing inventory control or processing orders. Employees rely on mobile phones, tablets, and desktop point-of-sale systems to look up inventory and process updates. In other cases, customers directly interact with self-service kiosks to view and order products. In a typical cloud-first architecture, there's a transfer of data between cloud servers and store devices. For example, the product catalog and inventory are transferred down from the cloud to those devices, and updates are pushed back up to the cloud for storage. Data flow from the cloud to in-store devices is a critical component of the retailer's backbone, one that requires high performance at scale, not just basic connectivity. What if the internet goes out? How can they ensure their business is not interrupted? The technical challenges and considerations for a retailer are substantial. Connectivity issues negatively impact everything from customer experience, cost of ownership, efficiency, business continuity, operational resilience, security, and AI-powered features, all of which suffer from any lapse in network connectivity. Now let's take a look at a product inventory management app running on Couchbase Mobile. This isn't a canned demo, it's a real-world reference app that shows how data actually moves across a distributed system. The application runs natively on iOS, Android, or within a web browser. All of these devices are running on a local network to simulate a physical store environment. There's a database server hosted in the cloud, which serves as the global system of record for the retail inventory. All of the applications running on the devices are fetching, sending, and synchronizing data with the back-end server. Here we see all three apps running side by side. The Android version running on the left, the iOS version running on the right, and the JavaScript version running in a web browser in the center. Suppose workers across the supermarket are updating inventories of the same brand of soft drinks, each using their respective devices. As each user updates the inventory of canned soda, Couchbase data synchronization keeps everything consistent in real time. But now let's simulate a network failure. I'll drop the connection completely from the web app. In a normal cloud-only application, the user would see a loading spinner and a please wait and please try again alert. Here, I can continue to modify the inventory count seamlessly. The application remains 100% functional because the data is served from the local embedded Couchbase Lite database. When the connection is restored, the backend automatically detects the web client is back online. It then seamlessly synchronizes the local data to the cloud and back to the other clients in real time. Next, I'll switch over to Couchbase Server on the back end, where we see the raw inventory data. If a stock quantity is updated in the cloud, the change is instantly synchronized down to all the clients in real time. As you can see, the updated inventory count is reflected everywhere. Now let's look under the hood at how Couchbase Mobile makes this possible. Embedded within the mobile and web applications is our Couchbase Lite database. This is a full-featured, embedded JSON document database with support for SQL, full-text search, and vector search directly on the device. It runs on iOS, Android, Java, JavaScript, .NET MAUI, and React Native, Flutter, and Ionic for cross-platform apps. It also offers a native C API for developing on any platform or custom embedded hardware, regardless of the language. In the cloud, we're running Couchbase Server, our massively scalable distributed NoSQL database platform with support for key value, SQL, analytics, eventing, and AI. In between is Sync Gateway, This provides secure data synchronization between the server and the edge devices. With this architecture, apps remain consistent and accurate thanks to built-in data sync, while the embedded database ensures the app is always on and always fast when the network drops, eliminating business downtime. For use cases that require data sharing in areas without internet, Couchbase Mobile provides two distinct options. The first is peer-to-peer sync, which provides data sync between mobile devices without the need for internet. The second option is Couchbase Edge Server, a lightweight, standalone database built for resource-constrained hardware like a single-board computer. It supports data sync with Couchbase Server and Couchbase Lite, and it also exposes a RESTful interface for simple data access. Let's take a closer look at peer-to-peer synchronization. Couchbase Lite peer-to-peer data sync allows teams to collaborate in real time by synchronizing data between devices, allowing users to share data in complete isolation. Here we see the Android version of the app on the left and the iOS version on the right in two iPhone simulators. Suppose the mobile app users are counting stock in the far reaches of the warehouse, where internet drops frequently. When we turn off app services on the mobile applications, we essentially disconnect from the cloud, simulating an internet outage. But thanks to Couchbase Lite peer-to-peer synchronization, the apps continue to synchronize data over local networks like Wi-Fi or Bluetooth. No internet required. Best of all, when just one of the peer-connected devices goes back onto the internet, all the changes captured in isolation are synchronized back to the cloud and the rest of the app ecosystem, ensuring that everything is up to date and consistent. While this scenario shows a retail use case, other use cases for peer-to-peer sync include field service, restaurant, or logistics apps, among others. This is how Couchbase Mobile eliminates business downtime for mission-critical applications. The unified capabilities of cloud scale, on-device storage, and comprehensive data synchronization combine to provide a superior customer experience, lower cost, higher uptime, greater resilience, and more stringent security for your mobile applications, as well as features to power the next generation of edge AI apps. This retail reference application is a showcase of guaranteed availability and secure data synchronization between Couchbase Lite embedded apps on mobile platforms and web browsers, and Couchbase in the cloud, illustrating the power of Couchbase Mobile for always-on, always-fast apps at the edge. Mobile and web developers, be sure to check out the source code on GitHub today, and thanks for watching.